Hello, this is Britt Caswell with another example video. In this video, I'm covering example 3 from section 3-4 in the SavvasRealize Algebra 2 textbook. So in this example, I'm attempting to relate the value of a function when I plug in a number to the remainder of the function when it's divided by that factor. And so this is called the remainder theorem for those of you guys who might need to look it up later. And what the remainder theorem says is that when I plug in the some number a, it will produce the remainder of the value, or the remainder of the division, I guess I should say, of p of x divided by x minus a. And so what that's saying is, if I have an expression and I divide it out, I can anticipate the remainder by setting this expression equal to 0 and plugging that number into the function. And that makes no sense when I go to describe it this way. So let's do the example, and that'll really help you to see it. Alright, so the first thing I'm going to do is I'm going to do synthetic division right here on this stuff right here. So remember, synthetic division, I take my divisor and set it equal to 0. And so I'm going to have a negative 2 outside of my division house. Notice that later, that's what I'm also plugging into the function. So then here's my division house, and I'm going to write out my coefficients. I'm not missing any exponents, so I can just write the numbers as I see them. So then I drop this down, so I have a 1. So negative 2 times 1 is negative 2. I add down. I do my multiplication, get negative 12. I add down. I do my multiplication, get 0. I add down. And here's my remainder. Now I don't really care about the rest of this. I mean, I can write it as x squared plus 6x plus 0. But really all that I care about is that remainder right there, that 5. Alright, so now let's switch gears a little bit. Now let's do f of negative 2. So I'm going to plug negative 2 into the function. I'm sorry if you guys hear Gyoza. She's having a rough morning this morning. Alright, so here I am. I'm plugging negative 2 in everywhere I see an x in the function. And now I'm going to evaluate it. So negative 2 cubed is negative 8. Negative 2 squared is 4, times 8 is a positive 32. 12 times negative 2 is negative 24, and then I have a plus 5. So now here, negative 8 and negative 24, together that's 32. And if I add 32 to it, those are going to all cancel out, leaving you with just the 5. So if you notice, when I plugged in f of negative 2, I got the same value as my remainder. So later on, what we're going to be doing is we're going to be using this idea in order to determine if a number is a factor or not. Alright, so there we have it. Until next time.